Google Cloud Run is a managed compute platform that lets you run containers on Google's scalable infrastructure. Cloud Run is serverless, meaning Google handles all the underlying infrastructure management. You don't need to provision, configure, or maintain servers. You can focus entirely on writing your application code. Cloud Run requires your applications to be packaged as container images. This ensures portability and compatibility across different environments. Cloud Run automatically scales the number of container instances in response to traffic patterns. It can scale to 0 when there's no traffic and rapidly scale out to thousands of instances when needed. Cloud Run supports multiple programming languages, including Go, Node.js, Python, Java, .NET Core, and Ruby. You can use your preferred language and framework. Cloud Run uses a pay-per-use pricing model. You only pay for the precise CPU and memory consumed during request processing, billed in 100 millisecond increments, plus a small fee per million requests. In summary, Google Cloud Run provides a serverless, container-based platform that automatically scales and charges only for actual usage, supporting multiple programming languages on Google's managed infrastructure. Serverless computing fundamentally changes how we think about infrastructure. In traditional computing, developers must provision, configure, and maintain servers. With serverless, Google Cloud handles all of this automatically. Cloud Run applications must be packaged as container images. This containerization ensures your application can run consistently across any environment and provides true portability. One of Cloud Run's most powerful features is automatic scaling. It can scale from 0 instances when there's no traffic to thousands of instances during peak demand, all without any manual intervention. Cloud Run uses a precise pay-per-use billing model. You only pay for the exact CPU and memory consumed during request processing, measured in 100 millisecond increments, plus a small fee per million requests. The Cloud Run developer workflow is straightforward and consists of 3 main steps. Write an HTTP server application, build it into a container image, and deploy it to Cloud Run to get a managed HTTPS endpoint. Cloud Run transforms the developer experience by eliminating the complexity of infrastructure management. Instead of spending time on servers and configuration, developers can focus entirely on building great applications. Traditionally, developers had to handle numerous infrastructure tasks. They needed to provision servers, configure security settings, manage certificates, and handle scaling manually. Cloud Run eliminates all of these infrastructure concerns. Google's managed platform handles the complex operational tasks automatically. Google automatically handles auto-scaling to match traffic demands, manages rolling deployments for 0 downtime updates, provides failover capabilities, and balances load across instances. Here's how rolling deployments work in Cloud Run. The system updates your application gradually, ensuring continuous availability while new versions are deployed. Cloud Run also handles auto-scaling seamlessly. As traffic increases, it automatically provisions more instances. When traffic decreases, it scales down to save costs. This automation allows developers to focus on what matters most: building application logic, creating user-facing features, and delivering business value. The Cloud Run developer workflow is remarkably simple. Write your application, containerize it, and deploy. Google handles everything else, from scaling to security to reliability. Cloud Run's auto-scaling is powered by Google's Borg system, the same infrastructure that runs Google's own services. This battle-tested system provides the foundation for Cloud Run's intelligent scaling capabilities. Auto-scaling automatically adjusts the number of container instances to match incoming request rates. When traffic increases, new instances are created. When traffic decreases, instances are removed to optimize costs. Here we can see auto-scaling in action. The top graph shows how instance count automatically adjusts to match request demand. When requests spike, new instances are created. When traffic subsides, instances are scaled down to save costs. One of Cloud Run's most powerful features is scale to 0. When there's no incoming traffic, all instances can be scaled down to 0, meaning you pay nothing for idle resources. This ensures both consistent performance during traffic spikes and maximum cost efficiency during quiet periods. Cloud Run uses a pay-per-use cost model that fundamentally changes how you think about cloud pricing. Instead of paying for allocated resources, You only pay for what you actually consume. Cloud Run charges you only for the CPU and memory consumed during actual request processing. This consumption is measured in precise 100 millisecond increments, ensuring you pay for exactly what you use. This contrasts sharply with traditional virtual machine pricing, where you pay for allocated capacity regardless of whether you're actually using those resources. Let's compare these two models. This pay-per-use model is particularly advantageous for applications with variable traffic patterns. During peak times, you scale up and pay more, but during quiet periods, your costs drop to nearly zero. In addition to CPU and memory charges, Cloud Run also includes a small fee per million requests processed. This comprehensive pricing model ensures you only pay for the resources and requests your application actually consumes. Let's compare Cloud Run with Functions as a Service, or FaaS, to understand when to use each approach. Functions as a Service platforms like Cloud Functions deploy small code snippets that are triggered by specific events. Each function handles a single task and runs only when needed. Cloud Run uses container images that package your entire application, including the runtime, dependencies, and web server. This gives you full control over your environment. Here are the key differences between these two serverless approaches. FaaS is ideal for simple, event-driven tasks, while Cloud Run excels at complex web applications and microservices. Cloud Run supports complex web servers and microservices while still providing serverless benefits like automatic scaling and pay-per-use pricing. This makes it more versatile than traditional FaaS platforms. While Cloud Run offers powerful auto-scaling capabilities, it can present several challenges that require careful consideration and mitigation strategies. Unpredictable costs can arise when auto-scaling is not properly bounded or when resource allocations per container are misconfigured. The solution is proactive load testing and implementing concurrency limits to forecast and contain expenses before they spiral out of control. The second major challenge occurs when Cloud Run's rapid scaling capabilities overwhelm downstream systems like databases or third-party APIs, creating bottlenecks. Connection pooling helps manage database connections efficiently, preventing overwhelming your database with too many simultaneous connections. Rate limiting and caching are additional strategies that help control the flow of requests and reduce the load on downstream systems. The third challenge is limited platform-level debugging capabilities. In extreme failure scenarios, your visibility is constrained by Cloud Run's managed nature. Strong observability practices become critical when platform-level debugging is limited. Comprehensive monitoring and alerting help identify issues before they become critical problems. By implementing these mitigation strategies, cost controls, downstream protection, and strong observability, you can successfully navigate Cloud Run's challenges while maximizing its benefits. Cloud Run ensures portability by using industry-standard container formats. Your applications are packaged in standard Docker containers, making them portable across any container runtime environment. Cloud Run complies with the Knative specification, an open-source standard for serverless computing on Kubernetes. This compliance ensures your applications follow vendor-neutral standards and can run on any Knative-compatible platform. This standards compliance provides clear migration paths. You can easily move your Cloud Run applications to Google Kubernetes Engine, other Kubernetes clusters, or any native-compatible platform without major code changes. This portability design future-proofs your technology investments. You avoid vendor lock-in, maintain architectural flexibility, and ensure your applications can adapt to changing business needs or technology landscapes without costly rewrites. Cloud Run's commitment to container standards and native compliance ensures your serverless applications remain portable, flexible, and future-ready across any container platform.